Today we're going to talk about sum and difference angle identities. So we have our three functions, sine, cosine, and tangent, and there are different rules for working with each of them. So if we start off with addition, we have the sine of A plus B is equal to the sine of A times the cosine of B plus the sine of B times the cosine of A. And so this is our addition 1. Likewise, for cosine, our addition rule is cosine of A plus B is equal to the cosine of A times the cosine of B minus sine of A times sine of B. And so now down to tangent, we have the tangent of A plus B is equal to the tangent of A minus or plus the tangent of B all over 1 minus tangent of A times tangent of B. So they look a little bit difficult, but after you memorize them, you can apply these in a bunch of different equations and situations that will be very useful. Now let's look at the difference or subtraction identities. So they're very similar. In fact, they are derived from the addition identities. There's just one small thing that we need to consider. So in this case, when I say difference identities, I'm thinking instead of sine of A plus B, we'd have sine of A minus B. So basically what we need to consider when we're looking at how we're going to get the difference identities from these three addition identities, we need to consider the behavior of the sine, cosine, and tangent functions, meaning that if we have cosine, the general graph of a cosine looks a little bit something like this, meaning that it is an even function. But our sine function is an odd function. What I mean by even and odd is that for cosine, the cosine of theta is equal to the cosine of negative theta. So it's like a mirror image of each other flipped on either side. And so when I say that sine is an odd function, I mean that sine of negative theta is equal to negative sine of theta. So what we have here will be, if we flipped it, it would be the negative, if that makes any sense at all. And so now we have tangent, and tangent is also going to be an odd curve. So we need to take these three into consideration when we're trying to figure out the formulas for our difference identities. So let's go ahead and attempt to figure out these difference identities. We'll start with sine, and we're going to take the sine of A minus B, and we're going to, instead of B here, we're going to substitute in a negative B, and then we're going to see what happens. So sine of A minus B is going to be the sine of A, like always, times the cosine of B, but in this case, B is going to be negative B, so cosine of negative B, but we know that the cosine of negative theta equals theta, so we still have the cosine of B plus sine of negative B, and we know that the sine of negative theta is negative sine of theta, so we're going to have minus here, minus sine of B cosine of A. So as you can see here, the only difference that we have between the difference and addition identities is that this little sign in here, S-I-G-N, is different, positive or negative. And so now we have our cosine. We're going to do the same thing with that. Oops. Cosine of A minus B is going to equal cosine of A times cosine of negative B, which is just cosine of B, minus sine of A, normal, times the sine of negative B. And sine of negative B is negative sine of B. So this is going to become a positive. We have sine of B. So as you can see here, the only difference once again is that the negative in here is now a positive. So lastly we have our tangent, which is also an odd function. So we're going to have tangent of A minus B is equal to, let's see, can you guys read that? It's equal to tangent of A minus tangent of B, because this would be negative B, and since this is odd, we're going to flip this over to negative tangent of theta, or negative tangent of B in this case, divided by 1 plus tangent of A times the tangent of B. So those would be our three difference formulas. And in my experience, I didn't really use the difference formulas as much as I just used these functions here. When you're given real numbers, if you're given something like sine of 30 minus 45 degrees, I would always just take these raw numbers and just go sine of 30 cosine of negative 45, just like that, and then I'd figure out what cosine of negative 45 was. So I didn't really have to hassle with the formulas, the different formulas for this. But on more conceptual questions, you might have to answer a question about this. Let's try an example. So let's say that we have the sine of 15. I don't know the sine of 15 degrees off my head, and if you're not given a calculator, you're going to have a very hard time trying to calculate this, especially if you don't have enough time to memorize obscure angle identity values of trig functions. So if you have the sine of 15 degrees, you can make it much easier on yourself if you say that this is the sine of 45 degrees minus 30 degrees. So we're going to use our difference formulas here, our sine of A minus B formula here, and we're going to say that A is equal to 45 and B is equal to 30. So now let's just use this formula here and see what we get. Sine of 45 cosine of 30 minus sine of 30 cosine of 45. And so now we have 45s and 30-degree angles, which we probably have memorized from our practice with trig. So our sine of 45 degrees is going to be 1 over square root of 2 times the cosine of 30 square root of 3 over 2 minus sine of 30, that's 1/2. Cosine of 45 is 1 over square root of 2. So now let's simplify. Square root of 3 over 2 square root of 2 minus 1 over 2 square root of 2. Now let's rationalize. Square root of 6 minus square root of 2 all over 4. So that would be our answer to sine of 15 degrees. It's kind of messy, but that would be our answer. Let's try one more. So let's say that we have the cosine of 105 degrees. I don't know the cosine of 105 degrees, and it would be very difficult to know this, let alone estimate it, if we didn't have a calculator. So let's say that we have the cosine of 105 degrees, and we're going to make it easier on ourselves by considering this as cosine of 60 degrees plus 45 degrees. So the secret is basically to take whatever number you have here and break it up into numbers that you know more about. So cosine of 60 degrees plus 45 degrees would be following our formula right here, cosine of 60 times the cosine of 45 minus sine of 60 sine of 45. So that mess right here is what we get. And so now if we just use our simple trig, we know that the cosine of 60 is 1/2. Cosine of 45 is 1 over square root of 2. Minus sine of 60, that's square root of 3 over 2 times sine of 45, that's 1 over square root of 2. So let's simplify. We have 1 over 2 square root of 2 minus square root of 3 over 2 square root of 2. And so if we rationalize this, we get square root of 2 minus square root of 6, all divided by 4. One last thing. So let's consider if A were equal to B. So if A were equal to B, we would have even simpler formulas to use. And we could simplify these formulas to sine of 2A, cosine of 2A, and tangent of 2A. So this is only if A equals B. And it's a little bit cool. So if we have sine 2A, we can convert this to sine of A cosine of A, because 2A is just A plus A, plus sine of A cosine of A. So we really have 2 sine of A cosine of A. I should have given myself more room, but that's what we have. So cosine of 2A, we're going to have cosine of A cosine of A minus sine of A sine of A. So now we have cosine squared of A minus sine squared of A. So that's our cosine. Our tangent is going to be a little bit more complex, but tangent of A plus tangent of A divided by 1 minus tangent of A tangent of A. So that's going to be 2 tangent of A divided by 1 minus tangent squared of A. So that's just one last thing that I wanted to add.